If any of you guys are here for COP points and you haven't checked in yet, go see Janae there in the back. She's waving her hand. Thank you. If everything I just said made no sense, then that's totally fine.
Might fill up a little bit. It might fill a little bit. Yeah. All right. Good afternoon, everyone. I think we're going to get going to be respectful of everyone's time. We have a great panel for you today. My name is Jonathan Mackla. I'm a faculty member in electrical and computer engineering, and I'm the associate dean for undergraduate programs. And I'll let Ian introduce himself.
Yeah, hello, everybody. I'm Ian Schrader. I'm the outgoing president of Engineering Council now, and we're really excited all you guys are here today for this AI panel, so thank you for being here.
Yeah. And so as we were working with Engineering Council and Engineering Career Services to put this together, we wanted to give our students, all of you in the audience, an opportunity to hear from industry, actually, how AI is being used in the real world, and hopefully have that help guide choices that you make going forward, right, in terms of courses you take or projects you take on. For those on the panel, first, thanks for being here. But this room is filled with undergraduates and graduate students from all the majors in the college. So it's not just computer science and computer engineering, although there are a lot of computer scientists in there. But I looked at the RSVP list. We have pretty much every major, as well as some majors outside of the college. So at Illinois, we have a lot of blended degrees in computer science and data science. So it's a pretty diverse audience. I know we also have some graduate students and postdocs, as well as a few secret faculty members sitting in, listening to hear what we can learn here as we work towards changing and updating our curriculum to take into account, sort of the industry trends here. So to give you a sense of what to expect over the next hour or so, we'll first invite our panelists to introduce themselves briefly. We then have a couple of pre-canned questions just to get things rolling. But then by about 5:35 or so, we're going to open up the floor to the audience here to ask whatever questions you have on your mind. So as you're listening to the first part of the panel here, keep the brain flowing in terms of what you would want to ask. Okay. So panelists, I'll call on you each individually to answer sort of the first question, just to briefly introduce yourself, your role, and then if you can quickly in a minute or two share one observation of, what is the single biggest way that AI has changed how you or your team does engineering work in the past year or two. And so I'll just go through the screen as I see it. So Monica, would you like to start off?
Hello, everybody. Can you hear me okay?
Yes.
My name is Monica. I have been with SAP for a couple of decades. For those of you who don't know about SAP, SAP is an enterprise software organization headquartered in Germany. We have customers across the globe. As a matter of fact, I would say 90% of world's transactions hit a SAP software one way or the other. My role at SAP is to lead the premium engagement business for the West Market unit. So you can imagine the Apples, Googles, Microsofts, Amazons of the world rely on our services to help their businesses run better. As far as the question goes, I am in a role which needs people management, sales leadership, and delivery excellence. So far, I have been using AI to do routine, mundane tasks. This means I continue to use my cognitive skills. I'll use AI to summarize long emails that have been sent to us. Many a times the emails don't come directly to us. It's various chains of forwarded emails that flows to me. And so I use that to summarize. I use to summarize or take action on the most priority emails. So out of 100 emails that touch my inbox in the first hour of the day, I use AI to prioritize where I could help make decisions faster so that the teams can get going. I also use AI to summarize the conversations that I have with my team members and managers. So one-on-one discussions, team meetings, using team meetings to record those sessions so that team members who are not able to attend those meetings can actually view a summarized view.
All right. Thank you, Monica. Next, Chinru.
Well, hello everyone. My name is Chinru. It's great be back to EIUC, at least virtually. So I did my undergrad here in the electrical engineering before heading to the San Diego for my master degree in computer science. And today I'm a senior software engineer at Waymo, which is an autonomous vehicle company where we developed a driverless vehicle. And my day-to-day focus here is to develop the autonomous vehicle perception and the tracking systems. Essentially, I'm working on the develop the machine learning system that help the car to understand and predict the physical world around them. So to answer the opening prompt, the single biggest way that AI has changed my daily work recently is how it completely transformed my day-to-day workflow. It's similar to what Monica just shared. A lot of, but more in the software engineering context. That is, a lot of our friction in the past was just to find information. Our company is very large. There's a lot of information hitting around, and of course, a lot of people. We need to do the communications, and the AI can help us alleviate a lot of tasks, such as writing boilerplate code, research dependencies, and stitch together all the internal documentation to give us the gist instantly. So I think here that is the trend. Well, I think what is hidden under this trend is that when all these tasks get offloaded, well, I don't need to do that much of writing repeated code, boilerplate stuff. And it actually forces me to think about something that is more complex, like system design. How do we prioritize the task? How do we develop the model? Those complex, tasks that become more and more important in my daily work.
Great. Thank you, Chinru. And we'll go apparently right next door, according to the background, to Shui.
Hi, everyone. This is Shui. Very glad to be here and talk to you all. I graduated in 2021 with a PhD in civil engineering. And I landed at a job at Google Cloud AI as a software engineer. I work on various types of the computer vision products and the research to productionization processes. So in the past 5 years, I've been launching tons of different AI products. And since in 2023, I've been working on Google's image generation models. To this day, that we have launched 7 models, including the old Imagine model period time and the latest Nano Banana period time. Yes, I'm a core member in the Nano Banana family, and I work on all kinds of interesting stuff and the cool visuals. To answer in the opening prompt, I'll just reply with a fun thing that I remember back in the time when we were preparing for Nano Banana Pro launches. And that was something around time back in October last year. And it was the first time we saw that how Nano Banana Pro model can handle very complex infographics. The presenter showed up and gave us a bunch of slides in the team meeting. And we saw, oh, okay, that's a very cool visual. How much time did you really spend on making those cool visuals? All the dots connected, everything seems to be in one single image, and the logic chain and thought flow seems to be correct. And he said that, yes, this is right coming out of our model. And we were so astonished that, wow, the image rendering, text rendering, all the concepts, all the logic flows can be so vividly delivered in a single infographics. Later on, we asked that how much time that person spent on generating those infographics. He said that, well, actually spent more time than most of us thought, because at that time, the model was not optimized for production, and each image takes about 50 seconds to generate, and he spent his entire 2 or 3 hours trying to get a perfect catch to present to us. So then we realized, okay, yes, then there's still some gap, but we definitely see the direction where this is heading to, and it gave us a lot of the confidence that the things that we're building would actually make a very great impact to the world or to people that we know. And we came to the conclusions that for when you're building some kind of AI models or AI products that can be potentially impacting end customer use cases, and if you're not part of the user group, that's probably the product not worth to build for. So that's a very cool insight that we got from our own, like dog fooding our own products and models. And ever since that, we feel very joyful to see all the new capabilities we onboarded and the new use cases that the community has presented to us. Yeah, that's pretty much it.
All right.
Thank you.
Thank you. And let's go to Mayank.
Yeah, thank you for having me. I'm Mayank Jha. I'm a senior machine learning engineer at Amazon Robotics, and it's great to be talking here to students. I work on a team called UMAMI, which stands for Unified Model for Autonomous Mobility and Interaction. The team's mission is to build a single AI foundation model that can control multiple types of robots. Robots that can move around warehouses, robots with arms that pick and place items, and eventually humanoid robots. So a lot of the tasks that my team does involves training models that are called vision language action models that came a year ago. So it involves a lot of ML ops, training models overnight, proposing the right reward functions and stuff. So I think the single most transformative change that the AI has brought to our team and engineering workflow are these autonomous AI agents, again, powered by these large language models, which have enabled us to run our training experiments 24/7 without any human intervention. These autonomous agents are able to propose the hyperparameter changes, run training on our GPU clusters, evaluate results, and also decide what to try next. Previously, our GPU clusters used to sit idle overnight because it used to involve a lot of human intervention, make sure that the training experiments are going fine, and if not, require manual intervention, stop them, and rerun them. Now we are able to run over 300 plus experiments per night autonomously. That has genuinely changed what a day's work meant for our team. So previously, we would be at a scale of 1 to 2 training jobs, and again, required specialists in terms of applied scientists or research scientists evaluating what our training jobs would be going like. But now we come in each morning to results that would have taken us weeks to do manually. So I think that there are like further improvements as we are talking, like there are like self-improving autonomous agents that are coming in. So yeah, I think it's been very transformative, and it has led to a paradigm where our team is able to focus on more specialized skill sets, things that matter to the team and things that are more research oriented rather than things that require like manual intervention and like automation in our sense.
Great. Thank you. So first question after those introductions, and some of you touched on this a little bit, but this would give you a chance to elaborate a bit. But walk us through how AI actually shows up in your day-to-day work, and what does it accelerate? What does it get wrong? And where do you still have to rely on your own engineering judgments? And just feel free to speak up as you have something to say here.
I think that the places where I rely on my own judgment is when I'm making decisions. I will never ever rely on AI to make decisions, particularly places where matters or decisions related to people and lives. That's number one. I will never be relying on people or I'll never be relying on AI to make irreversible decisions too. So many a times architecture topics, security topics, production decisions, they require experience, intuition, and accountability. So AI can do all the analysis, but it'll not own the outcomes. So for example, when I have to hire somebody for my team, I can ask AI to create a case study, but the decision to whether hire that individual or not would still be mine. There are things where the AI fails. So there are many things, designs related aspects as well, which look pretty good on paper, but they need somebody who's lived in the technology, lived in the industry to prove that AI is wrong. Many of you won't believe in the earlier days, if you would ask AI how many R's are there in cranberry, it would say 2. And then if you said, no, it's got 3 R's. So it would recalculate and then say, yes, it's got 3 R's. So AI comes across as confidence, but as I said, do not stop using your cognitive thinking. Use AI for repetitive, manual, error-prone activities only.
Yeah, I think just to second to what Monica said, I think decisions like system architecture decisions, deciding what are the integral items that need to go into the architecture itself needs to still be something that is like team driven, not like agents driven. I think what the team should be focusing on is, or like students that will eventually go into industry, is how do we set these safety constraints? What should automatically, for example, in my case, run a training run versus what's an acceptable exploration? I think it's fine for agents to make mistakes at certain levels. There are evidences of self-improving agents which make mistakes and iteratively learn on that. So I think the main question is, where do we draw a line? What is something that is going to hurt our security or safety constraints? And that's where like a lot of engineering or team domain specific solutions are going to come in. These guardrails is what is going to shape how these agents are being driven. I think in open research, there are things like OpenClaw, for example, which are like overnight running agents, and they are bound to make mistakes. But as long as you set the right guardrails, I think it is perfectly okay for them to make mistakes at a certain threshold. Even as humans, we do make mistakes and we learn from it. So I think we need to factor in what are we getting out of it, as long as it is within a certain threshold.
I guess from my end, I share a bit of a different story. What I really like about using AI to my daily work is that my job is to reach out every engineering component, every model work streams, that the individual work stream might not have the full context of what other work streams are doing. But since I'm sitting both on the research and the productionization side, I have to take a look at everything. That means that AI helps me a lot to go over what's the latest progress for each workstream and context to help me prepared on to how to talk to people, what they need, how to talk to people that's what's their daily work look like. So that helps me a lot to significantly reduce time I need to spend on reviewing all those documents and contexts, and help me to pinpoint the items that most matter to them, to the individual teams. But something I really like to work with a team that we share the same context and we both use the same agent or UI or AI to improve our work and to help our iterating. And I hate the most is that there's some very high level, director level leadership who happen to have enough context but not enough practice to poke into our code base. I think, yes, I like this feature. And I use whatever coding agent to help to create a new script. Can some of you guys take a look at the scripts? And yes, if it's okay that we can get this checked in. Well, because it's coming from a very high level leadership role and we like them a lot, we tend to go easy on letting these code changes or push to go into the code base. And later we find out it was actually making more mistakes than we spend a lot of time trying to fix his code. That's something that definitely see where that we can continue to improve on when AIs, and especially from people with a very rich knowledge and very rich context, but lack of the engineering practice to bridge that gap, to help a better engineering design principle and help a better context in how to avoid future tech debt that we're doing right now. I think right now Google is one of the examples that's pushing very hard and strong into turning to the AI coding practice internally. Yeah, we have an internal version of Anti-Gravity who has been on fire for the last few months. And pretty much everyone, whether you're in engineering role or not, or kind of a mandatory or like being pushed to use this jet ski or Anti-Gravity to do whatever job that you can do. And that creates a lot of good data for the Anti-Gravity team to train on.
So for me, I mean, I also want to share some of my opinion, but maybe from a software engineering point of view. I want to second like Monica's, like how it accelerates all the boilerplate and the easy coding stuff like firing bugs, all those simple things. They are handled by, they are accelerated by AI. But when I am interacting with AI, I find out that AI would miss the global context, which Shai touched. So sometimes when I give it a task, it will dig into the rabbit hole, try to figure it out unnecessarily, waste too much resource. And it could hallucinate. And another thing I find out is that like the AI, they don't have that kind of thinking out of box innovation capability. They tend to copy what is existing in the code design. So if if it was in the Shai situations, then I guess my AI would just keep following that wrong design, copy it, because someone has already set the precedence, and it was not being able to say no or innovate a new way there. But for me, what I would not use AI is to make this judgment call, when to cut, when to just stop that running, and make a global optimized design, and prioritizing what features we should investigate first. Those I don't think that is what AI can do.
Good. So most of you have touched on like the context, the broader context, and that there's something bigger that AI might be missing when it's working in an agentic form. So can you relate that to sort of any thoughts on the importance of the fundamentals of engineering, right? And I think one of the things our students sometimes get concerned about is, well, if I'm just going to be using AI, why do I need to take physics? Why do I need to take chemistry? These sorts of things. So can you give us a sense of how fundamentals still play a role or don't in your roles? And if you have any examples of where, because you understood the fundamentals, you were able to catch a mistake, that would be great as well.
I can take a stab at it. So when you are working with real world businesses, imagine a software is failing and it's leading to business down situations, right? So walking into a retail store, Trader Joe, Walmart, and they're not able to give you a receipt. So obviously you cannot get invoiced for what you've purchased, right? That's a traditional business down situation, right? Walking into a bank and the bank system is down, correct? Similarly, FedEx not being able to ship their orders, or a system is not performing optimally over the holiday season because of performance or peak volumes, right? AI systems can actually do the initial analysis of these problems. That's where you can use AI tools. Okay, have you tried this? Have you tried, the initial RCA and things like those? But when it's debugging real production down issues, you need human intervention. That's where your knowledge around physics, maths, everything fundamental is going to come into the picture. AI will not be able to debug or generate the real root cause analysis. Similarly, AI can help you build or design systems, let's say from scratch, okay? But in order to make it usable, in order to really productionize it, you will have to apply your brains and skills to make it usable. 90% of AI use cases fail because either the use case is wrong or it is not delivering the intended outcomes. That's where we need human brains and fundamental knowledge to be able to develop a system which is usable by others.
Thank you.
So
Yeah, I can do. Yeah.
okay, go ahead.
Yeah, I can give a concrete example from my domain that's basically a mix of engineering and machine learning. So I think once we start talking about agentic AI workflows, we fixate too much on the automation aspect, but the main crux or the main brain involved in those agentic AI workflows is the skill. So to develop those skills in those agents themselves still requires specialists that understand the concepts of machine learning, which again goes back to the same linear algebra and courses that require you to understand the mathematical concepts behind those. So for example, circling back to one of the cases that my team experienced a couple of weeks back, we have an autonomous experiment system that proposed changing the learning rate by 1/3. And mathematically, this is a very tiny change in a configuration file. But in this case, the agent had no way to know that this specific parameter, for example, is not the right one for this model architecture. And this would cause a bad orientation and would lead to the spike in our metrics by more than 40%. But because we understand the mathematics of the gradient descent and the loss landscape and the dynamics, we have built in the hard constraints that automatically revert these sort of experiments. So more broadly, and this connects to what folks in the audience are learning in the courses at UIUC. So understanding linear algebra is essential for understanding how these models actually work. For example, the fundamentals behind the attention mechanism, the matrix operations, and even for a lot of like engineering guardrails for that matter, probability and statistics are some things that I find will still hold a lot of value going down the line. So a lot of the skill that gets into the meat of these AI agents is still coming from the same fundamentals that are being taught in the courses. And I don't see this going away in any near future.
I agree. I often talk to people that in this era of time, the cost of execution becomes significantly lower and actually approaching to zero. Then that means that the idea matters more than the actual execution, because everyone can execute on a single idea and let AI to expand upon it and build the entire stack based on it. But that doesn't necessarily mean that those are the good executions. So idea really matters a lot, and following some very simple engineering principles can help you a lot. I always appreciate the beauty in simplicity and basic ideas such as divide and conquer. And one of the opposite example that I like to talk to folks is that when building some kind of an agent team, that many people simulate this agent team as dedicated characters and jobs, similar to a human organizations. I say, yes, this is a CEO agent, this is a CFO agent, this is an engineer agent, this is a reviewer agent, whatever that is. Actually, a very efficient agent system do not have to follow those human organization patterns. You can just have a very simple idea of breaking down tasks into subtasks and letting a single sub-agent to handle a wide variety of different tasks to do that and continue breaking that down. And the hardest part of that is to making the whole looping and reporting verification simple as possible. Because with EOS AI agent tools, you can build infinite complex way to verify and go into loop and just burning all your token limits. But the ability to directly assessing the results and in the most simple way, I think is just a very undervalued attribute in this era of time. And it takes years of training and practice to build and curate. And this, whether it's a research aesthetic or like decision-making process, it's something that I'm personally very interested into looking into in the next few years.
I also want to call out that the AI, even while they are also lacking this kind of like fundamental problem-solving skill, they also have limitations. Today's AI mostly is based on the data, which language, text, and the video, image, they are relatively easy to acquire from the internet. But the thing that I'm working on, well, it's driving on the road. It interacts with the human, and that involves a lot of physics and also a lot of culture, like societal culture surrounded. That kind of data is sometimes not collected, or it's not even sometimes not even trivially explainable to the machine. I will give two examples. For example, one interesting cases here is that sometimes in our vehicle, sometimes our perception system, they will generate a false positive pedestrian, say, and it will accelerate from 0 to 60 mph within seconds. It's impossible if you think about the physics. Like there's no human can accelerate that fast. Except Superman, of course. So I mean that means our AI model is actually hallucinating. It's pretty wrong. And if the vehicle thinks that there's a human, approaching it with such a high speed, it will just smash a hard brake and causing a tailgate collision, which is very dangerous. So that is where we really rely on all the physics, math, to ground it all our model prediction so that they are kinematically accurate, correct. And that is where we need to utilize the knowledge we learned in the college to help us make that judgment call and reject AI's prediction. Another part which I will touch is the societal and the humanity part is, for example, how do you deal with stop sign? Or let's say maybe green light for pedestrian. We know that we yield for pedestrian, but different countries actually have different policy, like or unspeaked policy. Like for in American, if that pedestrian is far away from you, like 10, you can make the turn, even it's a green light. People will not get offended. But in Japan, this is not okay. If it's green light, you have to stay there, wait until the passenger pass away, no matter how far they are. So this kind of very subtle things is not. I don't think it's even text in the book or wherever. And that is something where you have to learn the societal part from your education to make that judgment call.
Thank you very much. That's great insight. Next question is kind of more related on the student side and, on hiring and getting the job itself. So many of the students that are in this room might not be going into specific AI-focused roles. Is AI fluency becoming more of an expectation even for engineers that aren't in those AI-focused roles? Maybe think such mechanical, civil, systems, things along that nature. What does good enough in the sense of AI skills look like for new graduates who are trying to get jobs, maybe in one of those non-specific AI roles?
Yeah, I can take a stab at that. So in my organization, we have a mix of machine learning experts. We also have a mix of completely mechanical engineer background people because we need to prepare the assets for the robots. So I think a good enough categorization for a non-AI engineer today would still involve like some things on their end. I think the first and foremost that I can think of is they need to be comfortable using an AI coding assistant. I think no matter if you're going into AI domain or not, AI or work agents will become a thing that is not just something that is nice to learn, but it is going to be imperative for you to learn. It's going to be extremely essential to speedify what you're doing in your day-to-day work stream. The second is you need to be evaluating the AI generated content as well. So given that we have a large amount of code, whether it's AI or not, there needs to be some sort of understanding about what code it's generating and develop the skill set to debug a code. I think 10 to 15 years back, students spent a lot of time debugging code, but now with these AI agents, while it is producing a lot of code at a very rapid rate, the skill set to debug these vast amount of code may get lost. And I think that's where people who have this skill set will come in really handy in industry because we still need somebody to actually know and fix the things if it doesn't work, because a lot of time these AI agents may trigger some race conditions that may not be apparent to the robot. Again, it may be lacking some domain expertise or not. The third, again, as people who are going to be getting into the industry, we need to be understanding the basic vocabulary. For example, if you're going into uh, even a non-AI work stream, you need to understand what an agent is, how can you do automation, what a model means, what a training data means, what does overfitting mean, for example, because it doesn't matter whether you're working in a machine learning domain or not, you will be interacting with these agents and you will hear terms such as hallucination, and we need to be understanding what these actually mean. So I think 2 years back, some of these skill sets would have been in a category of nice to have. I think today, as I was talking about, we have mechanical engineers on our team who use these AI agents to generate like CAD scripting code. Electrical engineers use them to debug firmware, and a lot of product managers, they use it for documentation. So it sort of depends on what you're doing, but the interaction with these AI agents is going to become critical. So the more hands-on you are with this, it's going to help students getting into the industry. And also I think there is going to be some sort of paradigm shift in people who are specialists in certain fields to more or less like a generalist, because with these AI agents, you would be able to do more things that otherwise would have actually stopped you from going into certain domain because you lacked expertise. So yeah, what you don't need to do is basically learn intricate definitions about transformer architecture, learn how to train a model from scratch or read ML papers. I don't think so that's needed for everyone, but getting familiar and getting some hands-on experience is certainly going to be very handy. And that's at least some of the skill set that my team keeps an eye for when we are hiring for people. So yeah.
Just to add to what Mayank said, having interviewed at least 6 or 7 early talent students this week for our SPM Academy, I think in 2026 or beyond, most of the new grads would have used ChatGPT, Copilot, or similar tools. Most of you would have taken some of the intro to AI, introduction to AI, or introduction to a Gen AI course. Most of you are able to prompt LLMs to get usable codes and explanations. So when we interviewed these candidates, we had given them a use case, and obviously they were able to use some of these tools to present to us. The presentation skills of students has immensely increased. 20 years ago, if I would have interviewed or if I would have explained the same case study, I wouldn't have been able to explain the same way because I did not have those resources. But the graduates of today have those resources. They have the context. They have the information around it. But where things go wrong, right? If you're not able to explain where AI is good, where it's not, you cannot justify it. You should be able to justify when not to trust AI output. You should be able to validate or sanity check your results. This is what we call human in the loop. You should be able to validate the results coming out of it. So just to give you an example, they were able to amplify their case studies and give us a fantastic presentation, a presentation that we've not seen for years. But when you question them, you figure out how much they've learned, right? So when you question them, they're not able to understand the basic acronyms of the words that they've used. You ask them, do you know about BTP? You mentioned that, clean code or keeping the core clean could be done by BTP. Okay, what do you understand from BTP? No answer. Some people are able to explain that they don't know the terminology, but they understand how things work. That's where you are validating the outputs coming in from AI.
Great.
Sure. One of the greatest things I've always enjoyed when using all kind of tools and agents or models is that they can tell me something that I didn't know that I don't know. Critical pieces that should be relevant to my work, but I have no knowledge or context whatsoever. So I think this part of the professional training at school or at work is turn the student's mindset to a professional mindset. And the worst thing that you can do is turn yourself as a proxy to whatever AI answer gives you, and you just pass it away to your boss or your leadership. That's the least thing I would like to see candidates been doing. So use that as a preparation tool to help you to smoothly transfer into the professional mindset. It's something that would definitely like to see from the new hire. And in all kinds of probabilities, perspectives, such as the particular skill sets you're preparing, the knowledge sets, or the way that you should be able to approach to certain people, certain cross-functional team. There's all kind of a knowledge that's not taught in class, but somehow I'm very interested to find that because that the people are craving for all the information online or whatever information they curated. Some of these very strong and curious advices are actually included in the training sets, whether it's in the pre-training or post-training. So yes, I'm always be curious at what these models throw back to me every time when I ask a new concept or try to revisit an old concept, and looking forward that what are the new pieces of information that I missed before, and see that how can that help me to understand people or to understand my own skill set. Yeah, that would be something I've been pretty interesting and enjoying to work with what kind of models.
Yeah, I personally, I think there's a lot of good topic here, like use the AI to accelerate, knowing how to use AI to accelerate our day-to-day work and this problem-solving skill, and also this knowing how when not to trust AI. I just want to call out one thing. I kind of disagreed with Mayank when he talked about that anybody should learn like at least how to train or like what exactly GPT, what happened behind the GPT is doing, like a data training. I personally don't think that is necessary. I think everybody would be a domain expert in their own domain. People have limited bandwidth, so maybe understanding like how to like kick off a PyTorch, whatever, run on GPU, that is not super necessary. I think what is necessary is that you have this fundamental like the problem solving, the judgment. When it just treat it as another person gave you a report, but maybe you are a chemistry, but do you trust it? Do you not trust it? You make your own judgment. You don't just repeat whatever the AI says. So that's my take. I think not everybody need to spend their time like really go to understand what is training, what is data, but you have to be a confident your domain expert when you graduate from this university.
Yes, just for correction, I think I didn't mean for people to train models. I think I wanted students to understand what a model actually means, what agents or what models are behind those agents. For example, what would differentiate between a reasoning model and a non-reasoning model? When would you select a thinking mode on versus non-thinking mode on? When would you select a plan versus act mode? So that requires some intricacies on understanding what are the models behind those agents. I certainly don't expect anyone, especially like academic students, to be training those large GPT models because again, it's costly and time taking. But again, there needs to be some understanding of what agents or what models you're choosing for what specific workspaces. There are some models that are great at coding. There are some models that are great at generating images. So some level of understanding would be greatly appreciated if like students are able to develop those.
Thank you very
I agree.
much. Yeah, thank you. I think we'll move forward into our questions from the students. So we have Nora and Shreya walking around with microphones. So if you guys want to raise your hands and ask questions, and then please, when you ask a question, say your name and then your major as well. So yeah, we'll start here.
Hello, can you hear me? Thank you guys for coming here to talk, or at least virtually. My question is about the like an entry-level positions across a lot of fields. Like, it seems like a lot of the advice that you guys have is that you need some sort of expertise to validate these systems in a given field, and it seems that as an entry-level worker, you don't really have the expertise to validate the output of these whatever the AI is giving you. So, like, what is the role of entry-level positions going to change to in the future?
I don't think the role or expectations from entry-level students is going to change. We understand they do not have industry knowledge. We understand that they are coming in fresh and they would have to be trained on certain skills. As I said earlier, you should be just able to fast track your work using any of the tools that your organization allows for you. For every entry level position, organizations still plan for job boot camps. You would be still shadowing or taking a knowledge transfer from a person who's already playing the role. You would not be thrown on work at day one. You have to be getting a sense of the job expectations. You would be learning on the job. You'd be working with other experienced people on the job, and then you would be able to pick up activities which you're best at. Use AI only to make yourself learn. Your judgment, your foundation skills being taught with your basic courses like physics, math, whatever majors you are doing, that'll help you validate the outcomes being defined by AI.
Thank you.
Let's go to the next one.
Yeah.
Can I also add a little bit to the previous question?
Yeah, a quick one, sure. And then we'll go to the next
Okay.
question.
Okay. I mean, first of all, when you say, we don't know, like when you enter the industry, you don't know how to judge the AI. I don't think that premise is correct, because all the curriculum you trained in the UIUC, they actually give you that knowledge to do so. For example, if you take CS class, you know what is a race condition, how to prevent it. Or in the ECE class, you know how to design a multiplexer. What is the correct design for it? So these tiny, even maybe not a gigantic, how to design a driverless car system-wise. Maybe you don't know that knowledge, but if you break it down to a small piece, you know the answer, and you know how to make the judgment call there.
Yeah, thank you so much. My name is Tina, and I'm studying computer science. I have two questions, one for Shrai and then the other one for Manyak. So I'll go with Shrai first, because I recently read a Twitter report about GPT Image 2. Like they just released GPT Image 2 recently. They claimed that GPT Image 2 outperformed every other image generation models, including Nano Banana 2 and Nano Banana Pro, because you mentioned that you were also like a core member in this model. So I wanted to ask, what do you think of it? Have you personally implemented this model? And specifically, what are the measurements and the metrics that those big companies use when they claim that their models are better than the other one?
Mm-hmm. Very good question. I would not represent my company's view on competitors' models, but I do like to share one interesting fact. One of my previous colleagues, Marco also graduated from UIUC, he got hired by the very same GPT image team, the same day, the day before we launched Nano Banana. And because Marco works very closely with us on Nano Banana team, well, not directly, that the moment he saw those Nano Banana 1 results, he realized, oh yeah, this is going to be having a very hard time at OpenAI. And we see that it didn't really took them too long for them to catch up. And as a matter of fact, we've been sold out for 9 months, and that's a pretty long time. And we do expect people to catch up with that because there's actually no secret in Silicon Valley. One way or the other, the knowledge will flow. And we do have our tricks in the sleeve to prepare for the next few more generations to launch. And answer the second question, how companies evaluate or benchmark our models. Of course, we do internal benchmarking and third-party benchmarking. I think these days, one of the actual metric is a GPT. What that we internally value a lot is the GDP-driven metric. That's we at a certain time we already not looking into any academic benchmark. We start looking into actual people's battle leaderboards, and now these days we realize that the way people use those leaderboards might lead to some bias. We're not looking that either, but we're just looking at how much impact and we can enable people, and what's the actual users' feedback, instead of just going full on social impact or like marketing purposes. But I do have to say, yes, that's a very GPT Image 2 is a very good model, and I personally like it a lot. And we do know some of the people in that team that we've been friends for a very long time. So it's not like a competition that most people would imagine, that we don't talk to each other, we're not friends anymore. We're just being very keen on the topics that we talk about every time we meet. But yes, you know that I might be a part of that team someday soon. Yeah, you don't know.
Okay, thank you so much. Yeah. My question for Manyak is, because you said that like how AI integration in Amazon Robotics is able to reduce the like some manual intervention, human intervention. I'm particularly interested in that. So can you provide a more specific example? Is it something like similar to how AI model is able to tell a failure case from computer vision and then automatically execute a recover process? Is it something like this, or it's something something else going on in Amazon Robotics?
Yeah, I think I would say it's very similar to what Andres Karpathy's auto research repo sounds like. So I would highly encourage all students to just have a look at the GitHub repo on auto research. So it's extremely, I would say, informative. So the way it operates is, think of me as a human who's tasked to train models, or like, even in this case, swap out training models because I don't want it to be domain specific. Just imagine me doing a specific task. Now, in my head, I have the goals already set. What is my success criteria? What is my failure criteria? What are some of the ideas I can take in case my success criteria turns into a failure condition or something like that? Maybe what I thought would work does not work. So, as a human, I would take iterative actions on the evaluation of a certain task, make changes, adapt, and then rerun them. The way auto research operates is it has those conditions built in. And again, these are more or less self improving agents. So once they make a mistake, they are able to rectify themselves. So, for example, if it goes into gradient descent and identifies that a certain task was not something that provided and degree of improvement, it would not take that route forever. So it's just an action of me replicating more humans and be able to do more tasks that otherwise would have taken a lot more size of a team. So it's basically like an agent incorporating the skills that I had, but not requiring my time to run those tasks. Now, in this case, if I transition that to Amazon robotics tasks, again, I work on the machine learning domain, so it requires training those vision language models. Again, we have teleported data, which are gathered via human interaction. So all the details of what a good data set is. So for example, if I'm picking up an object, it needs to be clean. It should not be jerky. So those details are built in those agents as skills. So if it identifies that a training run did not produce meaningful results, it also goes back and checks whether my training data was correct or not, whether or not I need more simulated data in that case. So it's just like incorporating more and more skills from my team into autonomous agents that otherwise would have involved me talking to electrical engineers from my sister team or mechanical engineers trying to understand where the fault lies. But in this way, we are able to cross collaborate across different domains by incorporating those skills in those agents. So we have something, there are different ways to manage that, but we have a markdown file, for example. That's the simplest way you can do that. And you bring down all the rules and guidelines for a specific task there. So again, like as an example of picking up an object, a simple guardrail would be it should be clear and it shouldn't be jerky. And if it's placing a task, it should be it's placing an object in a certain grid. As simple as that. And there are more complicated things that maybe we can go in a later conversation, but these are the things that would be replicated in any other task that you do. So I don't want it to be domain specific. It's not specific to Amazon robotics. I'm pretty sure folks at SAP, Waymo, and Google Cloud are doing similar stuff. So yeah, I think that probably was your question.
I think
Thank you
what
so
we
much.
Mayank, is we rely on an ecosystem of partners who have their own LLM models so that, we are not reinventing the wheel there. What we also do is in order to, I think her first question was, how do you define the KPIs which let you choose which model do you want to choose? So what we typically do is we will look at the task completion rate. How fast did it complete the task? How correct it was. Is it like giving you the accuracy? For example, a model may let's take a very field level example. We're working with a leading apparel industry in San Francisco, and they would get their service orders in various formats via emails, via text, via Teams channels, via Excel documents. So how accurately this model can actually take all the inputs that we are providing to them in various forms or formats. So understanding these things and then how relevant the response was. So in a nutshell, for a person who is just picking up these models, we would like to categorize it whether it's able to detect bias, whether it's able to detect any kind of data privacy or sensitive data which should not be leaked, whether it's not, it's following the rules, it's not violating any kind of policy. So essentially, latency, token consumptions, and those things helping us understand. If you look at it from a very top level, correctness hallucination, relevance, reliability, cost and value. That's what we look at some of the LLMs that we would be using on. And I would like to announce to the host that I have to drop at the bottom of the hour to make an important sound announcement in my organization. So I'll take your leave, but it was very nice meeting all the panelists. It was wonderful meeting all the students. Thank you so much. All the best for your career.
All right. Thank you. And I think we are running up to the hour, so I think we will have to cut it here. Thank you to all of our panelists. We really appreciate the time that you've shared with us and the insights you've provided to our students. Thank you very much. Have a great evening. Thank you.
Thank you. Thank you for having me here.
Thank you.
Thank you.
Bye-bye.
Pizza. Oh, and there's pizza outside for you students if you want. Nope, there you go.
Cool. Works well. Yeah. Also, if you guys haven't gotten your COP points, if you're looking for COP points, Janae's out in the back for check-in if you haven't checked in yet.
We're determining whether or not we can share that or not. So we have to get the permission of all the speakers. Oh, okay. Hold on. Same thing. Out in the back, Janae.
I know, but like, what is that?
Oh, if you don't know what it is, then you're totally fine.
Do you know if it's possible for like contacting panelists?
They may be open to that. We'll ask them. Okay. Is there one specific or all?
Yeah, specific.
Which one?
Sure.
Sure. Okay. We'll see. Send me. Do you know Jay Makala? Yeah, you can find me. Problem. Oh, your name is Jay Makala. Jonathan Makala. So M-A-K-E-L-A.
Well done, sir.
Thank you.
So I can just like email you?
Yeah, email me and I'll see if I can get you in touch. Okay, thanks, John. All right, thank you. All right.
Done.
Success.
Nancy was here.
Okay.
She left. This is good.
Okay.
And she left.
I like that. Okay, we got Olga and Rebecca, and I saw Eric, and then Eric and Philippe is here.
You were turned this way, so I didn't hear you.
Okay, yeah, Philippe, yeah, Olga, Rebecca,